So today I will be talking about permutation groups. Mostly it is permutation like notation. Uh, so remember I was studying this book called AZ. Yeah, I am still following it. Pretty nice book for a layman. I am not a maths expert, but I don't think this is a rigorous book. I think it's a very good book for at least giving a taste, like giving some intuition about the topics. And so permutations I'm reading. Let us not get in all this book right now. I can't just go to those sections which I studied today. I don't want to waste time in searching them. I will just come to the point. So what does permutation mean here? So suppose you have like some alphabets A B C D, and I label their location initially 1 2 3 4. Like A is in position 1, B is in position 2, C is in position 3, and so on. What I can do is I can shuffle them. Yeah, basically shuffling is what permutation means. I don't know if shuffling is catchier to say than permutation. Why don't they just say shuffle? Shuffle is sounds cool. I don't know why. So shuffle. I will say shuffle. So I can shuffle these things in so many ways. Uh, let's say I will take this A and put it in C's place. Then this C is homeless now, and A spot is empty. Either I can place this A in this C spot, or I can again take this, and I know you know what I mean. I can just shuffle stuff up. So one of the shuffling I would like to show you. Let me say I do this shuffling. I want to shuffle this in this manner. So we have some notations for shuffling. Let's say 2 3 4. So what this 2 3 4 means? Okay, I will just make it more random uh, for no reason. Let's say 2 4 1. What this means? What this means is this is saying 2, right? So I will just go in the 2 spot, and I see that there is B. I will just pick this B up. So there is an empty place. There is no more B here. I just took the B out, and it says 4, right? I will just kick this D out and put this B here, and now D is outside. Poor guy. And now since this is saying 4 to 1, now B is here but D is outside. I will just go to this A's place, kick this A out, and put the D here, and now A is homeless, and finally one will go to 2. Basically it's kind of a cyclic thing, 2 4 1. Yeah, always it's like something like this. So now I will take this and put it in 2 spot, because remember this place was homeless since I took out the. So I want to show visually how it looks one more time. I don't know if I'm doing a good job in this, but let me try. And what was the shuffling I was supposed to do? Uh, what was the shuffling? Let me just write this in small words. It was 241. Let me try explaining this. I hope I do a good job. I have A, B, C, D, right? So first you look at this, it says 2, right? So what you do is, from the 2 spot, what take out the B. You just take this out, and what it says 4, right? So you kick this guy out and put the B here. Now what to do with this D guy? It says 4 to 1. So okay, no, I don't want this 4 to 1. So remove this guy. Okay, I don't know what's happening. Come on, I'm very bad at this. Let me do again. uh, I really hate this feature. I would like to do it again from here. I would like to do it here. Okay, you have to bear with me again. The same thing. I really don't like this rope feature, but right now it has some use, so I'm using it. But it sucks. It really sucks. A B C D. So it was, I guess, 241, right? 241. Yeah, 241. First, what you have to do? Take the element from the 2 spot. Oh no, shit. Take the element from the 2 spot. Take it out. Uh, then uh, put it in the 4th spot, and this poor guy who was in the 4th spot will go in the 1 spot, and make this one guy homeless now. Take this D thing, put it here, and then it says 1 to 2, and notice one thing that since throughout this nowhere 3 is mentioned, this means that this guy is safe. I could have done something else as well, like okay, well, that's what I do. I bore you, so keep watching. I just do shuffling in this. Yay. uh, let's say 3 4 1 2, all elements are involved here. So again I have these elements. Now I do the shuffling. It says 3 to 4, right? 3 to 4. So this means I just take the guy from 3, I kick out the guy from 4, uh, put this C, place it here, and now this D, what to do with it? This says 4 to 1, so I just go to the 4 spot, kick this guy out, uh, put this guy here. I know you might be thinking, why the hell am I doing this? This looks so complicated. I mean, this, even if it's simple, you might feel this is a headache, this is pointless. Well, even I think now it's pointless, but that's what the book said. I'm just blindly following it because I don't know anything else better to do. So I put this here, and finally, what did I do? I forgot again. Yeah, the guy from the one spot, I just placed it to the and you know what, in the middle, if I forgot what I did, it's over. I don't know what to do later. Yeah, and yeah, finally it says 2 to 3, and luckily you always notice in the shuffling, the element you started with, when you replace when you remove it, there will be this empty spot. There will always be empty spot from the guy you initially started with. I don't think it would always, I think it should, but whatever. So this, there is nowhere else to go for this B guy, so I will just take this and put him here. We successfully did it. We did the shuffling. Yay. So basically, if I do, so if I write it in some notation, initially it was like this, and I gave a shuffling code. The code was 343412, and this gave me something like this, DABC. So uh, now what more can I do? So I hope you got what I did, but actually there is another way to do this. uh, let's make things more complicated, because we can. This 3412 can actually be written something like this: 3 4, because there is 3 4, then there is 4 1, right? So you write 4 1, and then finally there is 1 2, right? 1 2. What do I mean is this: I have to go one by one. I will first do this, then I will do this, then I will do this. This is first, this is second, this is third. Let me show you. uh, let's say initially I had this 1 2 3 4, and below that you had elements A B C D. Now when I do simply 1 2, what happens is I just have to look element at 1 and element at 2 and just replace them, nothing else, no shuffling, nothing complicated, just replace these elements, and what you get is uh, 1 2 3 4, just replace them, you get B A C D, and then what is written next? 4 1, right? So you do the same thing. Let me do like this to save space, because I don't know why not, for no reason. 1 2 3 4. Now it just says in this look, any whatever is in the fourth position and one position, just replace them, and we're gonna do that. We're gonna replace D and B, AC as there, and finally the last step says 3 4. So again I'm gonna do the same thing. I do this 3 4. So just look at the 3 position and 4 position and replace them. Okay, so what would I get? Let me write down: 1 2 3 4. Then there is a DA. This will remain unaffected, and finally I have BC. And if you notice, you remember what we did here: 3 4 1 2. We got DABC. We again got DABC. So what I mean is, when you do the shuffling, what was the shuffling code? 3 4 1 2. The shuffling code 3 4 1 2 is equivalent to the shuffling code 3 4 4 1 and 1 2. The reason the reason we I think do this is easier to visualize. Maybe I mean you just exchange 1 and 2, then whatever the result is, then again exchange whatever is in 1 4, and then again exchange. It's like how should I say, a stepwise process. It's like you just decompose the shuffling into smaller chunks. Now you can easily see what is happening step by step. Here you just got it all at once. It's chaos. It's confusing. You are like, what am I doing? Where will what go? You can still, in principle, this is good enough, but I don't know. You just can do it. So that's it. That's all I found out today. I mean, nothing more than that. I I had I think I got a problem from thermodynamics in my mind, but I will uh, maybe I will make another video for it later. But other than that, that's all I did today. There was another thing I did it today. It took me 2 hours. I and my friend, we were just doing some math, and there was a question which said, suppose you have a group such that the number of elements in the group are even. Basically, you have even number of elements. So let's say the group was something like this. Yeah, it has an identity. Let me call x not identity, then x1, x2, dot 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 until some xn. So basically, the total number of elements in this group is n plus 1. So n plus 1 must be even. This thing is even. Now the question was, if the number of elements in a group is even, I have to prove that there exists at least one, at least one, some one element, let's say xj, such that it belongs to the group, which is not identity. This is not identity, and this element, the speciality of this element, when you square it, you get identity back. You have so that's the question basically. I think there are, you can try it. I won't give the answer. You just try it if you can. And the thing about proof of this is, it all depends on how much deep you want to go. If you want something just intuitive, just something to convince yourself, you have like simple ways. But if you are like hardcore math guy, you are like, no, I want every step to be explained in detail, you might, so you can go as deep as you want in this proof, I think. And so it all depends on you, what you want to do, whatever you would like. So this is one of the question. Some people might think it's a trivial easy question, some people might think it's interesting. It all still again depends on the person to person. Whatever it is, give it a try. That's it. And yeah, also, since this is since n plus 1 is even, n must be odd here. So yeah, and this is just my own convention. I just used it. The thing about question is, number of events is number of elements in the group is even. You can write whatever you want. This is just one of the ways of thought, maybe written as well in this way. So then what else can we do today? I mean, what else can I say now? Let me see from the easy book if anything interesting. Discrete or continuous? I don't think I got much to say. Relations and items of Lie algebra. I haven't gone through Lie algebra much, so I can't comment on it. But let's see what else we have. I think that's all for now, because I don't know. I don't have much idea of anything else. What is this thing, by the way? Exhibiting 3 of A4. What is this AS? I know S1, 2, 3, 4. Now what is this AS? I don't know. Tetrahedron A4. Okay, somebody was talking about it in my class today with this tetrahedron and stuff. E3, what is this? A3, A1, A2. I want to see now. Are they gonna go? No. all the way a1 a2 a3. So what is the question? Consider A3 the group of even permutations of three objects. Even permutations. Fine. It contains three elements. Identity. Okay, 1, 2, 3. And the anti-clockwise permutation 3, 1, 2. Okay. Mm, the group is abelian with A and C here, as was noted in abelian, as was noted in chapter abelian group. Abelian element is the single member of its own equivalence class. Okay, I have to know about equivalence class before I can do this. Maybe some other day. Okay, I can't do it today. So I don't know what exactly an equivalence class is. Equivalence class. If I know this, I could have talked about this, but I don't know what it is, so nope, I can't. Sorry, I'm a noob. Then, okay, in this same uh, anything more interesting? I don't think I have much interesting. Okay, in the same thing, I'm going off topic. I will just give a thermo question as well. I don't want another video for it. I will just talk some stuff about it and go. So the question is simple. Suppose I have a spherical shell, and in this spherical shell, let's say I have some gas inside. It's uh, I don't know if something like ideal gas really exists, but imagine this is very close to an ideal gas. This gas is very this gas like follows PV equals nRT to a very good range. An ideal gas inside, and suppose at I waited for this gas to reach equilibrium. This shell, this spherical shell has volume V naught. Let me write below. This spherical shell has volume V naught at some time instant, and this spherical shell has volume to some. Let me say pressure P naught, and some temperature T naught. Okay. What I will do now is, uh, I I will make a I will plot this. I will tell what I am doing. Suppose that this is the pressure and this is the temperature. Sorry, not temperature, volume. Okay, and I will measure all these things which I can measure. Of course, I can measure all three. I can measure easily. There is no problem. Nobody has any problem with this. So I will just put it here. Okay, let's say at some temperature T naught, I will have, depending on how much this is P naught and this is T naught V naught. So P naught V naught, right? Now what I will do is I will, so let's say that this shell is elastic. It has ability to expand, and uh, it is ultra strong, heat resistant. I mean, imagine it can like how should I say? It can take even thousands of kelvins, and still nothing would happen for this. Okay, this is a very nice, very strong material. This is made of some very strong material. We have let me go to call, what will this be? Super strong elastic, I will say. Okay, just elastic is enough. Elastic uh, balloon. Yeah, also not to forget resistant, thermally resistant balloon. It won't just melt or pop up when it is applied. Some hypothetical uh, balloon. Now you know that. So this balloon has, let's say, some surface tension properties like I don't know, like what those properties are. I think you might need to define it, but it must have those properties. And so the thing is, if I wait this to get in equilibrium at some temperature T naught, this balloon will apply some pressure from outside, the surface tension, the like the what do I call the elastic material of this balloon, the pressure from elastic material of this balloon, and the pressure from this gas will be in equilibrium, such that this balloon won't you know uh, keep expanding or keep shrinking. It won't expand because of the internal pressure from the gas, since it is elastic. Even though it is elastic, it won't expand, and it won't shrink because of the own pressure, own surface pressure of the own balloon. It is in equilibrium. What I will do is I will slightly increase the temperature. So let's say the next instant the temperature is T naught plus some delta T. Some temperature I increase, then I will wait. What would happen? I think intuitively, if you think, the gas will the balloon will expand a little, because the gas molecules will vibrate more pressure from the inside, and it will expand a little. Volume will change. Volume will also change, and pressure will also change. Pressure would change, right? I really don't know. I am taking, if pressure doesn't change, good for us. But I am just being very general here. I don't know if it could change or not. If it changes, this whole question might be pointless. And what I will do is, after some time I will just come here. So basically, this is my new temperature after some infinitesimal temperature change. Uh, some infinitesimal temperature change. Some volume also change. Basically, volume is V naught plus dV. A little. This dV is because the slight change in temperature. So and some pressure. I will do the same again. I don't know, maybe the next instant, let's say maybe it was here. Again it will happen. Oh, what am I doing? What is happening? Come on, math. Let's go back, and I will do this again. And I will keep doing that. I will, maybe I keep plotting, and I get some curve. That's what we do in physics, make curves. Now my question is, I don't know. I'm just making things up. I don't think that this is how the curve will look. Nobody knows. My question is, can you come up with a parametric equation, P of T, V of T? Basically, pressure and volume are depending on temperature. Given the initial boundary conditions that at some temperature T naught, you have volume is V naught and pressure V naught. Can you come up with equation of pressure with temperature, variation of pressure with temperature, variation of volume with temperature, and give me the plot? That's the question. And one more thing, if you think something is missing in this question, you may just make improvements as you think is right. Really, you're just open to do anything, as long as you give me this curve and explain to me that what all assumptions you take, like what all you assume for this boundary to be, if you took any what do we say, surface tension coefficient or something like that. So that's the question. And what else is there? I think that's all for today. I mean, nope, that's all for today. Thanks for watching. If you did, I don't think anybody will, but yeah, bye.